Please introduce yourselves.
We are the Robo Raptors from St. Christopher School in Vandalia, Ohio. We now have a team chant.
Raptors. Woo!
We would now like to individually introduce ourselves. My name is Lily. This is my 4th season on this team.
Hi, my name is Brendan. This is my 1st year on the team.
Hi, my name is Ryan. This is my 4th year on this team.
Hi, my name is Paige. This is my 4th year on this team.
My name is Anthony. This is my 4th year on the team.
Hi, my name is Alex, and this is my 5th year on the team.
Hi, my name is Brandon, and this is my 1st year on this team.
We would now like to share our skit. The Mandalorian and Grogu are walking through the streets of Navarro, and they see a teenage boy in a wheelchair. The boy looks lonely as he cannot play basketball with other kids due to his physical limitations.
Young man, what's wrong?
I wish I could play with the other kids.
I'm Mando, and this is Grogu.
My name is Noah.
Come with us, and we will take you to a doctor.
Mando, Grogu, and Noah travel to Camino.
How can I help you?
Can you help this boy Noah get physical activity?
Yes, it's great that you're helping him. Let my medical droid assess him.
My scan indicates that you are 15 years old. Your vitals are normal. I noticed you can only move your right arm up and down.
Are there other individuals with a similar condition as Noah?
My medical database tells me that 500,000 individuals in the Outer Rim have one or more symptoms similar to him.
Do you get regular physical activity?
Due to my limitations, I'm not sure what to do.
Just moving your arm in a repeated way would be enough to get your heart rate up.
A boy your age should get at least 30 minutes of physical activity 3 times a week.
Is there a way for Noah to play basketball?
Go to Tatooine. Ask for the Jawas' help.
Mando, Grogu, and Noah travel to Tatooine and find the Jawas.
We heard that you can help this boy Noah get the right amount of physical activity he needs.
Yes, we have invented a device called the Assist.
It allows people with limited mobility to play basketball.
All you have to do is pull the string to shoot the basketball.
Once the ball is shot, it will come down the ramp and fall through the opening at the bottom.
The ball then reloads itself into the shooting mechanism.
Give it a shot.
Look, I did it! That was amazing!
How much do I owe you for this device?
It costs 250 credits and 9 credits to replace the ball the green child ate.
Okay, here's the money. Thank you. Let's go home. This is the way.
We now have a project presentation.
The problem we identified was that individuals with significant physical limitations have little to no access to engage in sports. Physical activity, even if limited, increases heart rate and improves overall health. We partnered with the Heart of Unlimited Boundaries in helping David, who is shown, who has severe cerebral palsy, to play basketball.
Our problem solution is the Assist, an automated basketball shooting system. The system is comprised of the components shown here.
The team used design matrices to complete the select the components for the Assist. We brainstormed options and criterion and rated them based on our research.
Our prototype was refined using identified problems feedback. For instance, a safety switch was added to protect the users. Protect the users. We received feedback from Rocky Grimes Jr., the owners of Papa Shot, and several physical therapists.
The assist has 3 modes. Mode 1 is for individuals with significant physical limitations. In this mode, the catapult automatically aims and is activated by a cord switch. The algorithm is shown here.
Mode 2 is for individuals with less significant physical limitations. In this mode, the user now has to aim the catapult.
Mode 3 is for rehabilitation and strengthening. The cord switch is now pulled and held to aim the catapult and is under adjustable tension to provide resistance exercise to the user.
We brainstormed and researched many problems and possible solutions related to physical activity during the replayed season.
We have a video we'd like to show you.
This diagram illustrates our research progression, including experts contacted as we worked towards our final problem and solution. Do you have any questions? Here's our robot design presentation. Our goals were consistency, efficient changeovers, and good teamwork. We used a sign-up sheet for in-person robot work, so all team members could work on robot despite COVID restrictions. We rated and grouped missions based on complexity and their location on the field map. Our main design principles were keep it simple and be repeatable. Team members used a brainstorm, prototype, test, select, and refine design process. We used a Gantt chart to guide robot development. A digital robot binder was shared with the team to communicate robot status.
The front of the robot has magnets to quickly connect and remove attachments as shown here. This video shows our transformable jig that is used to align the robot at launch. The lance attachment is used to quickly complete the step counter mission. We launch blocks using inertia as shown for the CRAPS mission. We use the Tooth of Destiny, which can only rotate in one direction to snag and release the row wheel.
Parallel operations were used to allow motors to be overdriven without stalling the program or to perform multiple tasks at the same time. The parallel operation shown here is used to complete the treadmill mission with moving motor A and moving the arm, and motor D turning its wheel. Mission programs were made into My Blocks and then entered into a master program. In between each mission program, a loop waits for an EV3 button on the robot to be pressed to start the next program. An initialization program is also used to test the sensors and to initialize the gyro. Please allow me to introduce you to our new best friend, Smalls, and all of his attachments.
The exoskeleton was used to protect the wheels and improve rigidity when handled. We designed the robot to allow for easy access to the EV3 validator and ports. We created a replica robot friend, shown here, to allow for socially distanced co-creation of attachments while in person. The robot and attachments were designed to be sturdy and dependable.
To help the team understand and modify the code, comments were used in the program. Variables and constants were used to allow for a quick value adjustment during testing. Frequent operations were placed into my blocks for cleaner and quicker coding. For example, this is the gyro turn my block. The program first reads in the desired turn angle and the current gyro angle. In the loop, the drive motors run in opposite directions to rotate the robot, and when the change in angle equals the desired angle, the loop and motor stop. The software uses cutter sensors to follow and line up on the black lines, a gyro sensor for more repeatable movements, and running into and along machine models and tables to better locate the robot.
We ran robot and code updates multiple times to understand their typical behavior. Each attachment and jig went through many iterations to improve performance. For example, the evolution of the treadmill mission is shown here. The top pictures show the progression of the code for the bench mission, and the table below provides a few samples of the many other robot and code refinements recorded in our robot binder.
Test data was collected during the refinement process. Here we see measurements of where the robot stopped when following the line for a present duration. On the left, we see test data for launching the yellow block into the target area. And for the wheel speeds in the follow the line codes. On the right is test data taken during the final refinement process of the programs. As the teams prepared for the competition, many other tests were performed, with test data recorded in our robot binder, including for the gears used, color sensors, reflected light values. Do you have any questions?
Now we would like to share our core values presentation.
Once upon a time, there was a team of 7 children bringing awesome opportunities to their community.
This is the Robo Raptors robotics team. The team founded all of their work on the base plates of respect, cooperation, listening, responsibility, dedication, teamwork, creativity, communication, service work, reliability, leadership, and focus. And don't forget about
Fun.
The team knew they needed leadership, so they elected a robot, project, and overall team leader.
The robot and project leaders documented and guided the team's progress on each aspect of FLL. They also updated the Google Classroom with each practice's homework.
The team leader helped coordinate teamwork challenges and service activities.
The team is most proud of the way they still participated in FLL this season, even though they had to take safety precautions. They continued their participation in service activities and have shown true optimism. They have received recognition for their gracious professionalism at every competition.
The team overcame many challenges, such as having to practice robot with the school's safety precautions and having to work on the project over a Google Meet.
Some of their accomplishments this year included adding 2 new team members, using gears for several robot missions, working virtually on the project, and handling extreme temperatures when working on robot.
Most of the team's goals for the season have been met, including being more organized by using a Google Classroom, keeping robot programs straightforward and repeatable, and having Gantt charts to stay on target. This is the end of our presentation, but we hope this isn't the end of our journey. Do you have any questions?